Here's Jed Haile. He's lead security architect at Nitro Data Systems, and he's doing his presentation on Hogwash.
Yeah, I'm Jed Haile from Nitro Data Systems. My normal full-time job is building data management solutions for large-scale security information databases. In other words, if you're generating lots of security data from firewalls and intrusion detection systems, etc., I specialize in helping you capture and keep and analyze all that data. But what I'm here to talk about today is gateway intrusion detection systems. So what's a gateway IDS? A gateway intrusion detection system is an intrusion detection system that behaves as a network gateway. In other words, it sits at the entrance to a network and analyzes the traffic as it goes through. And the idea behind a gateway IDS is it goes a little beyond a firewall. A firewall is able to look at the destination and the destination port and where it's coming from, those sorts of things, and make a decision on whether or not the packet's allowed to pass through the firewall. A gateway intrusion detection system's goal is to do deeper inspection on the packet, to actually analyze the packet for malicious content or other content that you don't want to allow into your network. And if it finds that sort of content, it should drop the packet. So ideally, a gateway IDS should be able to drop any attacks on your network. Now obviously we're far from perfect there, but that's the general goal, is to be able to stop all known exploits. I could say right now the state of the art in gateway intrusion detection systems, you can basically reliably stop any known exploit. If there's an exploit floating around out there, it is possible to detect it and stop it. Of course, it's really difficult to stop attacks that you don't know about, and that's when you have to rely on good system administration policy, proper networking policies, proper system configuration, and all those other things. So here's some comparisons between a gateway intrusion detection system and a network intrusion detection system. A gateway intrusion detection system, again, acts as a network gateway. It decides what enters or leaves your network. A network intrusion detection system, on the other hand, can only observe network traffic. It sits in parallel to your traffic. It watches the traffic go by. It analyzes it. It generates alerts, all that stuff. A gateway IDS will stop packets that it doesn't like. A network intrusion detection system will generate an alert and will log the packet, but it can't stop the packets in general. Now, there are a few intrusion detection systems that have some sort of active response mechanism where they attempt to modify a firewall rule, or they'll send spoofed resets or things like that to try and tear the connection down, but that's not 100% reliable, and there's a lot of problems associated with that approach. A gateway IDS should be able to prevent most successful intrusions. It's particularly useful for dealing with things like worms, like if you have a large network full of IIS web servers, and this is where Hogwash got very popular. Back in the Code Red days, people would have these large networks full, especially service providers, people like that, where they had a bunch of IIS systems that they didn't own. Someone else actually owned the system. They were just providing the network and the infrastructure. And a lot of those people were lazy and wouldn't necessarily patch their machines so that Code Red wouldn't get them, and it created a terrible problem on their network. And so one of the things that got really popular is they would only use Hogwash just to stop Code Red. And that was a tremendous value just there for a lot of people. A network intrusion detection system can tell you you've had a successful attack. It can tell you Code Red's owned one of your systems, but it can't stop it. It's up to the sysadmin or the network admin or somebody to do something about it, which means you have quite often a lot of lag time between when the intrusion is detected and when something's actually done about it. Now, on the downside, on a gateway IDS, false positives are a very, very, very bad thing. If you have a rule that's dropping packets and it shouldn't drop, then you're breaking stuff. You're gonna break services. It's hard to say, exactly what might break. Now, on a network IDS, if you have false positives, it can be a real burden for the analyst or for the person that has to look at all the data that the system's generating, but the odds are it's not going to actually break any network services. That's a very important difference. And for a long time, people really thought that gateway intrusion detection would not be practical because of the false positive problem. Now, in our experience, we've discovered that if you very carefully configure your system, if you're very careful about the rules you allow in your system, you know, if you really use rules that you only know are truly accurate, then they're an extremely valuable asset to have on your network. So here's Hogwash, a little more in depth about it. It's based on the Snort intrusion detection system. It's actually more of a wrapper around Snort. So the way Hogwash is built, Snort sits at the core of the system, and Hogwash is a bunch of bridging code and other code, and it also extends the Snort rules language so that it can make drop instructions and things like that. And we'll get a little deeper in that in a moment. The operation is very similar to a bridging firewall. It has two interfaces in it. It sits on your network. Packets go in and out the two interfaces, and Hogwash makes a decision about forwarding the packets back and forth. Yes, sir? It does not, no. The question was, does it use the Snort flexible response module? It uses a different mechanism. Since a gateway IDS lives directly in line, it touches, every packet has to pass through the system, so you don't have to spoof a response. You have control of the stream, so all you have to do is say, I'm not going to let this stream happen anymore. You know, or you just have to say, this packet doesn't go anywhere, and you don't allow it to be bridged. And it will generate and send resets back, but it does not use the flexible response stuff. So the basic idea is you can write Snort rules using the normal Snort rules language that, you know, more likely than not, if you work in intrusion detection, you're familiar with Snort and its rules language. The only difference is now you can write rules that say, instead of saying alert or log, you can write rules that say drop. And I'll show you some examples. Hogwash is compatible with a lot of the Snort plugins. Particularly, it's compatible with a lot of the output plugins. There are some problems with Hogwash and a lot of the preprocessors that actually alter or re-inject content into the packet stream. So all the decoder plugins like HTTP decode and the telnet normalization stuff, Stream4, Frag2, a lot of important Snort plugins don't work with Hogwash. Now I've addressed that, and we'll get to that later in the presentation. Hogwash is freely available under the GPL. It's got a website out at sourceforge.net, and the URL's in the presentation here towards the end. So the basic theory, just to summarize, it's like a bridging firewall in a lot of respects. It is a system that's capable of making forward and drop decisions. And like an intrusion detection system, Hogwash can examine every part of the packet. It can examine the Ethernet header, the IP header, you know, the TCP header, the UDP header, whatever sort of header's next, and it can examine all the flags, it can examine the payload. The whole packet, you know, anything that the Snort rules language gives you access to, you can use as part of your decision-making process. Here's a typical installation. I strongly recommend that you keep your firewall. Hogwash was not designed to behave as a firewall, it's designed to behave as an intrusion detection system. What that means is it doesn't really have a lot of the features that you're used to having in a firewall. You know, it doesn't understand making routing decisions and things like that. It doesn't do NAT, it doesn't do a lot of those sorts of things. So you'll still need a firewall. All it's really good for is examining packet content and making a decision if that packet should be allowed to progress or not. So in this diagram, you can see some people will put Hogwash in front of their firewall, and that way you can write rules that will protect machines on your DMZ and machines on your internal network. That's a really popular deployment model for people who have a DMZ full of mail servers and web servers and things like that, because then they can protect their web servers from code red or from command.exe attempts, or, you know, from the various PHP exploits that are floating around and all those sorts of things. So here's the new keywords that make all this functionality more or less apparent to the user. There's drop, and this will kind of get back to your question, sir. Drop will drop the packet. If the drop rule rings, it will drop the packet. It will send a reset in both directions to tear the session down, and it logs the packet, so you can analyze the packet and make sure that packet was the kind of packet you actually wanted to drop. Ignore will drop the packet, but it does not send a reset. Okay, so if you wish for some reason to drop the packet quietly and not reset the connection, you can use an ignore rule. Now what sdrop does is it will drop the packet and it will send a reset to tear down the connection, but it doesn't generate an alert and it doesn't log the packet. Now that's desirable if you have, for instance, code red's another great example. If you had a code red rule that was shutting down code red, you didn't necessarily want that thing to generate 50,000 alerts a day saying, yeah, I dropped more code red, I dropped more code red. You know, that just clogs your logs up. You really don't want to know. All you care about is knowing that code red's being broken. So sdrop will silently drop the packet. It won't log the packet. It won't generate alert or anything. It just does its job and goes on. No logging, which is really nice for things that you know you want to drop and you really don't care to log it. Okay, I mentioned earlier that we can't do traditional stream reassembly. What that means is a normal IDS, there's a certain likelihood that an exploit or the signature you're looking for will be divided across multiple packets in the stream. And Snort is a packet-based detection engine. In other words, it examines one packet at a time, looks at the packet, says, is there anything bad in this packet? No. Is there anything bad in this packet? On and on and on like that, one packet at a time. Well, to get around that, Snort does some stream reassembly where it'll take packets according to certain rules and put them together into a super packet basically. And that super packet then goes through the IDS and is also checked. And in normal Snort, if one of these reassembled packets generates an alert, then you alert. Well, that's not going to work because Hogwash, you can't take this new packet, this re-injected packet that Snort's created, and stick it back on your network. That's no good. You can't drop it because you're not actually dropping the offending packet. And you're right, the offending packet is some other packet that was reassembled in this big one. So there's a fundamental problem there. And our original solution in Hogwash is this. What Hogwash will do is it'll watch for a partial match in the packet. And it looks for it at the end of the packet. You know, so if it sees a partial content match at the end of the packet, it'll say, oh, I've got a partial match here. It'll save the packet. And then each time another packet comes in that happens to match the previous one, sequence-wise, etc., it'll put those two together and take a look and see if the full string is matched or not. If it is matched, it drops the second packet. You know, and by dropping the second packet, you've still broken the attempted exploit because only half the payload got through. So this is something I like to refer to as opportunistic stream reassembly. You're not reassembling every stream all the time. You're only reassembling in the packet content itself that you need to do some reassembly. It happens to be pretty efficient. We've hit user to say, okay, here's how many packets I want to keep cached in memory for. And we've found in a lot of places these parts are trying to mess around with you. So it will keep. We've seen in a lot of the installations where these cached packets will actually stay in a circular buffer for days at a time before they finally, before the ring buffer goes around and overwrites them again. So it works really well unless somebody's deliberately trying to screw it up. That's true for any IDS. They generally work really well unless someone's deliberately trying to screw it up. Defeating port scans. This is another important thing. You know, if a bad guy is going to attack your network, the first thing he's going to try and do is conduct some reconnaissance on your network. He's going to go through and he's going to see what machines are there, what services are offered on what machines. He's going to try and deduce, you know, what version of the services are running. He's going to try and deduce what sort of OS is running, and you know, he's going to try and gather as much data as possible about your network before he actually perpetrates his attack. Well, ideally, you'd be able to defeat this port scanner and make it so that he could not even conduct reconnaissance on your network. You'd make it so that it's impossible for him to walk through your network and detail all your services. So I wrote a port scan detector. It's in Hogwash. It's also part of Snort. And this port scan detector is a session-based port scanner. So each time a new session is initiated by somebody outside your network, it makes a note of where it came from and where it was going. Okay, and if you think about it, when you do a port scan, if we're using a very simple session, where basically you define a session as being a packet going from here, from, you know, to this source IP on this source port, then you have a very rudimentary session engine. And so each time we see one of these, we make a note of it. And then we track all sessions coming from a host until that host goes idle for 60 seconds. So if you send a bunch of packets and then you go idle for 60 seconds, all his old sessions will time out and they'll flush out of memory. The point is as long as he keeps sending packets, even if he's only sending one packet every 60 seconds, you'll continue to store all his connection history. And the basic algorithm is if you see 20 unique connections to ports, or 5 unique connections, 5 connections to unique targets, then he's tagged as being a port scanner. Or if it's some combination of those two. Maybe he hits 4 ports on 5 targets, and that, or 5 ports on 4 targets, that adds up to 20 ports. Yes, sir?
Those don't have to be complete connections. All it has to be is one SID packet coming in.
Yeah, his question was, do those have to be complete connections, or can they just be a single SIN packet? The answer is yeah, just a single packet is sufficient. The way the tracking system works, it knows, okay, you send a SIN packet to port 80, you send a SIN packet to port 25, you send a SIN packet to port 22. Then you go around and you do that, hit those same 3 ports all over again. It will only show up as 3 sessions. It wouldn't show up as 6, it'd show up as 3.
But it's still counting.
They count, yes. They count. Sends count, pings. It keeps track of ICMP, TCP, and UDP. So even if he just comes in and does a ping sweep of your network, as soon as he's pinged the first 5 machines, he's going to get blocked. So that's basically what happens. As soon as this guy has triggered one of these conditions, it'll start dropping all subsequent packets from that port scanner. In the back?
How is that block based? The address?
How is the block based? It is based by IP address, yes.
Would that allow the attacker to spoof SIN plugs and proxy servers around the internet and people not be able to get to your website?
Yeah, there's a denial of service possibility. Now, the idea is as soon as, unlike a lot of systems where these sorts of things happen, that other people have written systems like this, but when the port scans are triggered, they actually alter a firewall rule, and the firewall rule remains in effect for some period of time. The goal, and if he spoofs from multiple sources, he's going to have to spoof enough from each multiple source to make each of those sources individually appear as a port scanner. Right, he can't do one from source A and one from source B and one from source C, because the port scan detector will see each of those as an individual attempt. I mean, it won't correlate and say, oh, those are all from the same guy.
Right, but 5 packets from
5 packets from each could be enough. These thresholds are configurable at runtime. And again, you have to remember that as soon as he goes idle, as soon as any one of those goes idle for 60 seconds, it quits dropping and you're back to normal. So he's going to have to constantly sustain this sort of effort to keep you shut down. As soon as he quits, and you could trim that down to 10 seconds if you wanted, because your timeout is configurable also. So if you're worried about that sort of thing, trim it to 5 seconds, so he has to stay really active. I found 60 seconds to be a pretty good compromise between catching the slow scanners and not being too adversely affected by denial of service attempts. But in the interest of knowing that every network's different, I made it configurable. So if you only want 5 seconds of timeout, you'll get 5 seconds of timeout. If you look in the current CVS of Snort, the question was, is this using the same port scan detector that's in Snort? The answer is sort of. I wrote a new port scan detector. If you guys keep current with Snort CVS, there's port scan 2 in there. Port scan 2 is a new port scan detector that I wrote that is much, much, much more accurate than the original port scan detector. And you can actually configure and run both of them if you want, but this stuff uses port scan 2. Yeah, and there is an ignore variable. So like for instance, the question was, it had to do with DNS servers and things like that triggering.
Hosting our DNS, specifically global DNS requests when you get through.
Right. His question is, global DNS requests will trigger this sort of port scan detection thing. There is an ignore line, so you can say, ignore my DNS server, ignore things that you find are troublemakers. For instance, a lot of people have an auditing system that goes out and does pings, to make sure everything in the network's up. You want to put him in the ignore line so he doesn't get marked.
Yeah, but there's a long conversation, but basically the DNS request are going to
Well, yeah. But they're always going to hit the same port on the DNS server, so they're not going to, you know, unless you have 6 DNS servers on your network and they're hitting all 6 of them, you know, they're not going to trigger because it's always going to be traffic back and forth between the same ports and the same target. Yeah. You know, so that one triggers a port scan. Now, you will quite frequently see, because of the nature of the way a DNS server behaves, if you don't ignore your DNS server, it may interpret the DNS server as port scanning because he's going off and talking on all sorts of different ports to different people. So things like, you know, all your servers you'll probably want to ignore, because obviously if your security's good, or if you haven't been owned, your servers shouldn't be doing port scanning.
Are you able to statistically monitor the types and numbers of connections that are being connected?
It logs all the connections.
I mean, you didn't want to log IPs per se, but you just wanted to establish
Okay.
how many different connections are being made.
His question was, are you able to statistically monitor the connection data so that you can generate statistical information on trends? Is that more or less what you said? There is code in the conversation engine, the engine that keeps track of all these states, that is designed to basically dump a line per connection of the pertinent data. You know, source destination, source port, destination port, duration of the connection, the number of bytes that were moved, the number of packets that were moved. It is possible to log that data, and then you can pump it into a database or write some analysis program and then analyze that data. Yeah, that's some future work I want to do, is engineer some better analysis tools for that data, because it's very valuable data. Or use Argus.
You run a separate rule sets for your inside and outside interfaces?
It does not, no. The question was, can you run separate rule sets for inside and outside interfaces? No, you can. Basically, in your rules, you can say, you know, in your rules, the rules are configured such that you have a source and a destination if you want. You know, so you could actually run duplicate sets of the rules where one set, you know, one set is set up so as to monitor your internal network, and the other set's set up to monitor your external network, and then that would effectively watch either interface. Over here.
If I have a large number of hosts on the inside reaching out to an individual host on the outside, would that reply traffic coming back trigger this little?
No, it wouldn't, because a conversation engine would mark it's stateful enough to understand the return session, saying, oh, you know, that's just, it keeps state like that, just like a stateful firewall does. Sir? Possibly. The question was, do I have plans of making the log data compatible with the database logging in Snort? I'm a busy guy. I do actually, you know, professionally I do full-time database development of that nature. Although I'm not the same Jed as the Jed who wrote the database plugin for Snort. That's Jed Haile, and I'm Jed Haile. Funny name collision. But I've considered doing it, yes. It's a time and an energy issue. He was pointing out that there are tools on using flow export to export a lot of this sort of data that the gentleman over here is interested in. Any other questions on this?
I mean, just going back a little bit to the log, is it using Barnyard or something so people can write logging? For example, if you don't want to do it, maybe somebody can just write a Barnyard plugin to write to my people?
Yes, I have preliminary support for unified output. His question was, will this write a unified output format file that Barnyard can read? And it's coming very shortly. I have the code, I just haven't completely got all the kinks worked out of it. But yeah, that will be available real soon. I've been very busy lately on a bunch of new functionality, and we'll get to that here in a little bit. Any other questions on this? Okay, great. How are we doing? All right. And if I have time at the end, I'll actually demonstrate how this port scan stuff works. Okay, content replacement. I work with the Honeynet project, and this technology is actually being used as as the access control device on the Honeynet. And if you guys attend the Honeynet presentation tomorrow, I'll talk a little bit about how we're applying this technology to Honeynets and how it's useful there. And this content replacement is something I wrote specifically for the Honeynet project. And what it gives you the ability to do is actually, since the packets are flowing through this device, it has the ability to rewrite content on the packet. It can rewrite packets. And so I added a replace keyword to the rules language. And the replace, it allows you to take a chunk of the payload in the packet and replace it with some other chunk that you choose. There's an example rule there, and it's looking for traffic going to your IIS servers on port 80, and it's specifically looking for the content command.exe. Now normally you would hopefully never see anyone accessing command.exe on your web server. This rule is not perfect, but it's a simple example. To make it perfect, I'd have to make it more complicated, and kind of ruins the educational value. So anyhow, all this does is it simply looks for the content command.exe in a packet going to a web server on port 80, and if it sees it, it will replace it with yyy.yyy. So what the web server at the other end would actually see, it wouldn't see command.exe, the web server would see a GET request for yyy.yyy, which breaks the exploit. That's the goal. And we did this so that we didn't, if you have someone that's attacking you and you don't want to tip him off that you're dropping your packets, but you don't want his exploit to be effective, you rewrite the exploit so it's broken. And that way the packet goes on through, and then he just sees the page come back from the web server saying, I don't know what that is. And the hacker's none the wiser that you're interfering. That's the goal. And it works very nicely. And any content in the payload can be replaced, and it doesn't have to be ASCII content. It will work on binary content also. So you can feed it a binary string, and if it matches that binary string, you can feed it some other string to replace the content. It's pretty nifty functionality. I like it a lot, and it has a lot of applicability if you're doing a Honeynet type of application where you don't want the hacker in your Honeynet going out and hacking somebody else, but you also don't want him to know that he's in a Honeynet. So this is a way of breaking his exploits in a way that's very, very difficult to detect. It's just like, why does my connection keep getting reset when I know there's a web server there? It's like, must not be vulnerable. Okay, here's the basics for running Hogwash. Basically, some of the rules options look like normal Snort, some of them don't. You run Hogwash. -C is where you're going to point at your configuration file. -I is a pointer to your internal interface. -E is, that's your device name for, so like be ETH0 and ETH1 on Linux. -L is your logging directory if you want to configure a logging directory. -N is a no rules mode, and this is just, if you run Hogwash -N and give it an internal-external interface, it'll run without any rules, which means it'll just sit there and behave like a bridge, and it'll bridge packets back and forth and back and forth and back and forth. So if you want to test the bridging code in Hogwash, you can run it that way, and it'll just happily sit there and bridge packets back and forth, and you can try to break it. -K is for an S control file. I'm not going to go into that today. Basically, an S control file enables a protocol that lets you actually remotely control the Hogwash box without using TCP, without actually having an interface open. But it's a little involved, and I decided not to get into it today because I have some other stuff I want to talk about. So here at the bottom of the screen is an example of how you would get Hogwash running. It's pretty simple. If you've run Snort, it's not hard at all to make Hogwash run. Okay, here's the new stuff I want to talk about. One of the big nightmares, I've been working with Jason Larson and some of the other Hogwash developers for the past year. We actually introduced Hogwash to the world last year at DEF CON. We took a Red Hat 6.2 box and stuck it on the Capture the Flag network, and we put a Hogwash box in front of it. And it was a brand new, it was a little compact, a nice little box. And we told everyone there on the Capture the Flag network that if they could break into the Red Hat 6.2 box, I'd give them that box. That was a challenge. We left it on the capture the flag network for, they didn't know that I'd spent the previous 2 months finding every exploit I knew of for Red Hat 6.2 and had written signatures for it. And it was a default Red Hat install though. Yeah. No, it just sent resets. It just sent resets. Yeah, well, no, I was just resetting connections. But the great part was at that point I didn't have port scan detection working, so the hackers could port scan the box. They could nmap it and they'd say, oh, it's Red Hat 6.2 and it's got every service known to God running. And they'd say, great, this is an easy target. And they'd go and they'd fire all their exploits at it and they'd break. And it was tremendously frustrating. It was so funny. So we had it there for 3 days and we watched hackers hit the thing and hit the thing and hit the thing. And they never got through. It survived 3 days on the capture the flag network. I thought it was a pretty good result. Anyhow, going back to it, so Hogwash has been around more or less for a year, and I've spoken at a couple conferences about it. The big problem with Hogwash as it's currently architectured is Hogwash is a wrapper around Snort, and it's not officially supported or worked on by any of the Snort development team besides myself. I'm a Snort developer and also a Hogwash developer, so I'm already wearing 2 hats. And the big problem I had was every time that Snort, I had to make enough changes down inside the Snort source code that it wouldn't cleanly patch back with Snort CVS. So anytime stuff changed, they'd have to go in and manually backport it into Hogwash, and it was very time-consuming and really slowed development down, because I was spending more time trying to keep up with all the changes in Snort and didn't have a lot of time to update Hogwash. And Jason, the other developer, was staying really busy with the bridging code, and it turns out that writing good bridging code is a really problematic thing, and making good bridging code that's cross-platform is even more troublesome. And so we'd had our share of problems with the project. And so a couple weeks ago, I finally got tired of maintaining compatibility between the two and convinced the rest of the Snort development team that I can add all the features and integrate them cleanly into Snort and basically make Snort capable of running in an inline mode. So here's what we do. We got inline Snort now. We've taken the core Hogwash functionality, the ability to drop, the ability to do S-drops, the ability to do ignores, the port scan detection stuff, the content replacement stuff, all these core features that I've spent the last half hour talking about, and put them all into Snort, cleanly merge them into Snort. And this gives us the following advantages. First of all, one of the big problems with Hogwash is we've never been able to find someone for the project who would do rules maintenance for us and make sure that we always had a rules file with all the current Snort rules, and that we had a set of rules that had been well tested and we knew they were reliable and we knew they wouldn't break your network and all that other stuff. And that's a lot of work. Well, Snort.org already has a very well developed rules effort going on. And I've been working with Brian Caswell and the other Snort and the other developers to generate official Snort.org rules database support for an inline Snort. So in other words, if you want a set of drop rules that you know will work reliably without being, without breaking your network, you'll be able to go to Snort.org and get one and it'll be up to date. So that's the first big advantage. We'll have that. The second advantage is now that all this stuff's merged into Snort, if there's a bug, it's now a Snort bug, and all the other Snort developers will feel duty-bound to help me fix it. Any of them here? No, they don't like to hear me yaks. They go to the other stuff. Some of the Honeynet guys are here. So we have a larger pool of developers, which is great. The big advantage for all you sysadmins and people who are actually running these things is now you just have to keep Snort current. You don't have to worry about keeping Snort current and keeping Hogwash current. They're one and the same. And now Snort, you either run Snort as a gateway IDS, or you run Snort as you always have done, which is as a network intrusion detection system. And also, the technology is not as radically different from Snort as Hogwash is, so it's even easier for all you Snort users to understand how it works and get up and running. You don't have to remember 2 websites, you don't have to remember 2 different sets of developers and all those other things. It's all the same effort now. So I'm really excited about this. I worked pretty hard on it the last couple of weeks getting it all done. Now as far as I know, I haven't really spoken much with the other Hogwash developers. I believe there will still be a parallel effort, and they'll still be doing stuff with Hogwash, but they have some different goals. They're trying to add more router-like functionality and some stuff like that to Hogwash. And I wasn't as interested in doing that. I was interested in making Hogwash more Snort-like. So in some sense, it might be a fork, but if you're using Hogwash, don't despair. The rest of the development team is still doing Hogwash, and I'm now working with the Snort team on getting as much of this functionality as possible into Snort. One of the things I did was I threw away all the bridging code because it was too hard to move. So here's how it works. Inline Snort now uses NetFilter. Now NetFilter is the generic name for IP tables, which is the Linux firewall. And NetFilter has a really, really neat feature, and that really, really neat feature is called IPQ. IPQ gives you the ability, your firewall will receive a packet, and then before it makes a final decision, it hands that packet to some application in user space. That application in user space is now Snort. Okay, so your IP tables firewall will get it. It can run it through all its normal firewall rules that you have configured, and then if it decides it's going to forward the packet, it can go to Snort. And the Snort can do all of its analysis, and it goes back and tells IP tables what its decision is, if the decision's forward or drop. So that's the general idea. So now you have IP tables doing what IP tables is good at, which is bridging and firewalling. And you have Snort doing what Snort is good at, which is detecting intrusions.
That means you can also change your rules to work on the basis of ports as well.
Yeah. Yeah, the question was you can change your rule set to work on the basis of ports. There's a lot of synergies in here that we're finding where the combination of IP tables and Snort are tremendously powerful. Another great thing is a lot of people have asked me for a Hogwash box that can do natting. Well, there's no way in the world I wanted to attempt to write NAT code for Hogwash. Well, now you just configure, your queues on IP table, you configure your chains, I should say, to do NAT, and it'll NAT for you. It'll NAT, just like IP tables has always done. Or any of those other little bits of firewall functionality that you would like your gateway IDS to do, but I was never going to get it coded. And this also gives the advantage. There's scads and scads of people using NetFilter and using IP tables. That code is solid. There's not as many people using Hogwash, and the bridging code still had some quirky little bits to it. There's just lots of special cases you have to work out to make sure bridging always works perfectly. And now the IP tables guys can worry about that, and I can just worry about making the actual detection core work as well as possible. Another beautiful thing about this is I got to re-architect the whole way packets flow through, and now all the plugins work. So previously there were a bunch of plugins that wouldn't work with a Hogwash. Stream 4 works, Defrag 2 works, what are some of the others? HTTP decode works, the telnet normalization stuff, it all works. Figured out a way to make all that stuff work. And it's transparent to the user, so you don't have to use these multi-rules anymore. You don't have to use the multi-content rules. You just write your rules and you count on the stream reassembler to do the stream reassembly and the defragmentation and all that stuff for you. So it makes your job as a rules writer a lot easier. You don't have to say, now which of these rules might be in fragmented or in separate packets. Just let the stream reassembler take care of it for you. The big disadvantage is it's Linux only right now. If you want to use this elsewhere, we need IPQ support. Are there any open? Yeah, I'll get to that in a moment. To build, okay, it's a little harder to build this guy. Normal Hogwash just builds pretty much for anyone as long as you have libpcap and libnet installed. To build inline Snort is a little trickier. First of all, you have to enable inline mode. So you'd run a configure like you normally do when you build stuff, and you pass the configure option to enable inline. And then I'll go through when it builds and enable all the inline functionality as part of Snort. I chose to make it a compile time option so people wouldn't accidentally turn it on and then have goofy stuff happening. You have to intentionally enable it. And then you run make, and it should build correctly if you have libipq installed. And we'll go into how you get that in a moment. Red Hat 7.3 does have IPQ support in the kernel, so if you're running a Red Hat 7.3 box, and I think it works in 7.2 and maybe even 7.1, I'm not sure, I'm using on a 7.3 and it works just fine. But you have to have IPQ compiled into the kernel, And that's down underneath the net filter options, or the IP table options when you're building the kernel. You can go in there and enable IPQ if it's not in your kernel. It's a fairly, it's a pretty simple thing to change. And you'll also need to have libnet installed because it still does use libnet to craft the reset packets. Okay, if you don't have libIPQ on your system, to make it build you need the development libraries, and to get those go to netfilter.org, and you get a current IP tables and tarball, and then to install it, you don't have to rebuild all your IP table stuff. If you untar it, all you have to do is go in and do a make install devel, and what that does is it installs all the IP tables development stuff, and then that'll give Snort what it needs to build. So all you have to do is that, and then you can go to packetfactory.net, and Mike's not here, download Mike's wonderful library, libnet, and install it. Okay, so to configure IP tables, there's one little magic thing you have to do to make the queue happen, and that is you have to instruct the firewall to pass the packets through this queue, because there's this queue that's feeding Snort. So first of all, you're gonna load the kernel module that handles IP queuing, and so you do a mod probe IP queue, and then you're gonna add to your input chain, for instance, a -j queue. So that says, after you've gotten done going through your input queue, jump to the queue, to the IP queue, and at that point it takes care of passing the packet into Snort. Now, an important thing to realize is if you enable this functionality, if you put queue onto your IP tables firewall, it will drop packets until you have an application running at the other end of that queue, like inline Snort, that makes decisions on those packets. It'll just start dropping them. So if you're gonna enable this and all of a sudden your firewall breaks, it's because you haven't fired up Snort yet. So you have to enable this on your firewall and then immediately fire up Snort, and then it'll start moving packets again. I have a basic IP table script at snort.org. All this, like I said, I've really put all this together in the last couple weeks, and I'm still working with the rest of the Snort team to get everything formalized. But real soon, this will have its own dedicated web space out at snort.org, and we'll put documents and all the other stuff out there. Yes, sir. This is working with Snort 1.9. This is the cutting edge development stuff. Yeah. Okay, now what? So what do we do next? Well, you're going to configure your rules file like you normally would. If any of you who use Snort, you're going to go through and you're free to use any configuration options you want. They should all work. With the exception of log TCP dump, it's got a small problem, but I'll have that fixed probably tonight. You change alerts. Any alerts where you actually want them to be drops, you change those to drops. And then you run Snort with a -Q, and the -Q will enable the inline mode. So if you run Snort with a -Q, you don't give it an interface name. You don't do like the -I ETH0 or anything. So it's not looking for an interface anymore. Snort's going to acquire its packets from IP tables. So basically that -Q substitutes for your interface argument, and the -Q says get your packets from IP tables. And it should run at that point. Here's a couple sample rules, kind of thing you do. You can see these look like normal Snort rules with the exception of a drop at the front instead of an alert. The first rule up there would just drop any incoming port 80 connections. So if you're wanting to be really rude and deny port 80 connections, that's how you do it. The second one would drop any command.exe attempts to your web coming into your port, your network on port 80. Those are simple rules. I wouldn't really recommend running those on your network. They're intended to be examples. Okay, more what's coming in the future. This has yet to merge into CVS. It's happening. I've got a couple of the other guys reviewing everything I've done just to make sure I haven't done anything really boneheaded. And then we're going to merge it into CVS, and so if you do a CVS update, all the code will be in there. The rules database is something that we're in development on right now, so that's coming. Documentation, I've already got a couple of volunteers to help me with the documentation. And also, since the Honeynet project's going to be using this stuff, they've got to document it for all the Honeynetters, so I've got I kind of get some great help from there too. The other thing, do I have any OpenBSD developers here, please? I really want to add, I've heard a rumor that OpenBSD packet filter is adding queue support for packet filter, just like IP tables does, but I've not been able to verify it, and I haven't been able to find an OpenBSD developer to ask about it. I know they're floating around the conference. So if any of you guys know of developers here, point them my way, and if I can find out how this works in OpenBSD, I'll make Snort support OpenBSD as well in this mode. And there's a lot of other new features that we're working on. Important things to remember in the end: a gateway intrusion detection system will bust the living hell out of your network if you're not very careful. Okay? Test, 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 test. One of the great things about this is you can write your rules first as alerts. You write your rules as alerts, let them run, and make sure that the alerts are, when the thing alerts, look at it and make sure that the alerts are alerting on what you expect it to alert on and not doing something goofy. Once you're happy that the alert rule is working properly, change it to a drop. You don't have to write a drop rule and put it out there cold, So write it as an alert first and then change it to a drop once you're satisfied it works right. Inline Snort or Hogwash both still understand alert. They still understand all the normal Snort stuff. You just have some extra functionality. And again, I'm a big advocate of defense in depth. This is not a replacement for a real full-blown dedicated firewall admin by a competent firewall admin. It's not a replacement for an intrusion detection system doing a lot of the other things that intrusion detection systems normally do, which are more along the lines of analysis and health keeping and that sort of thing. It's definitely not a replacement for proper system patching and taking care of your systems. You got to keep taking care of all that stuff. Just because you have another tool in your arsenal doesn't mean you abandon all the others that have served you well. Here's some references. Hogwash.sourceforge.net is where you can get Hogwash. The second URL is where I have a tarball of the latest stuff. We've been playing with it the whole conference. Lance has been running it on his virtual Honeynet stuff. You have too, Rick. And a couple other people are playing with it here. So if you want to wander by the Honeynet desk, we have it in action there. I'm going to do a quick demonstration since we have a few minutes left of some of the basic functionality. I have an article up on Security Focus about how we used Hogwash to secure an old IIS-3 system that had a bunch of had some vulnerabilities that Microsoft was refusing to patch. They told us to upgrade to IIS-4. Upgrading IIS-4 wasn't an option because the application that was running on that web server was written with a whole bunch of ISAPI that was unique to IIS-3, and there was a company depending on that application. It was their main source of income. So we had to basically protect that machine from getting rooted until they could rewrite the application to a more sane architecture. So that's that part. I'm going to put the mic down for a second and jump out of VMware here and try and demonstrate some Hogwash function or some inline Snort functionality. 1 second. Okay, I have running here, we'll stop it real quick. I have running here inline Snort. Oh, lovely. No, denied. That's looking a little better. Now I can see it too. Okay. Yeah, let me see if I can make the font a little bigger so that all you poor people with eyes as bad as mine can see it. Font. Try huge. Is that any better? Are we off the side there? I can move windows around so everyone can see. Let's nudge them over some. That's somewhat better, down a bit. Okay. So what you guys see here on your left is how I might run Snort. I've already got IP tables enabled. This is the basic IP tables in the window on the right. This is the script that I gave the URL to. It's very simple, you can see. I put a couple modules in. I turn on IP forwarding. Actually, that's not the one I want to show you. Hang on a second here. Where'd it go? That one. That's Well, this last part's the relevant part. You can see right here where I'm turning on queuing, and you can see I set all my other firewall policies basically to just default let stuff in, okay? That's I'm not sure where I put the other one. I'm not sure where I put the one that actually stuck up on snort.org, but it's in here somewhere, and I'm just scatterbrained to find it right now. Okay. So I'm going to run Snort over here. It's off and going. And you can see, going up through it, I've got frag2 running, and I've got stream4 running. I've got HTTP decode running. Conversation engine, that's the session engine that actually makes the port scan, that feeds sessions to the port scan detector. Port scan 2 is running, and I've got 1200 Snort rules loaded. I have it right now, it just echoes crap whenever it sees packets. And we're doing great there, it's seeing packets. We can take a look at my rules file real quick if that's going to interest you. And this is just the default Snort rules file, and you can see I've got my honeynets set right here, which is my IP address. Going down, I defined external net to be anybody. And I set a bunch of these other variables just to make sure all the rules were happy. Set my rule path right, oops, right here. So I can find the rest of the rules file. Some other junk. Frag2 should be on. We saw that. It's right there. So you can see this is a normal Snort configuration. Stream4 is on right here. HTTP decoding's on. The back orifice detector's on. Now, I haven't gone through all the detectors yet and hooked them up so that they'll drop when they detect stuff. I'm still in the process of doing that. The most important ones are done, and we'll get through the rest of them here shortly. Okay, here's port scan 2. I mentioned that you can set up ignoring. Here's how you set it up to ignore a machine. I basically set it up, to ignore my IP address so that, when I'm out surfing the web and accessing my email and doing all that other stuff, I'm not going to mark myself as a port scanner, because I've made too many connections. Here's where I have it, logging, full alerts. Okay, and then from there I have all the rules files included. Now if we look at one of the rules files, let's see, do I have scanned up? You can see I've just taken, actually we just use a little sed script to do this because I'm being really ornery about it and enabling all the rules. I just took a little sed script that took all the alerts and rewrote them as drops. So there's a bunch, you can see all these rules are drop rules. So it's ready to drop all kinds of garbage. Is anybody else on the wireless network here? Okay, hang on a second. we're going to check the log files here in a moment. Yeah, well, hang on. We're going to do that here in a second. Let's watch the log files. Okay, oops. Actually helps if you tell what file you want to tail. Hey, somebody port scanned me. When was that? 1833, yeah. Okay, and okay. On the left-hand screen, we're watching the alert file, you know, so if something happens that Snort detects, we'll see on the left-hand screen an alert generated. On the right-hand screen, we're monitoring the scan log. And what it does is, if a port scan is detected, every subsequent packet that happens will put some statistics of what we saw happen in that file. And that just kind of gives us a way to see what the port scanner was actually trying to touch as he was port scanning.
Can you make those fonts larger again, please?
Oh, yeah. Oh, this is a different, yeah, let me do that here. He wanted me to make the fonts larger, like that. I wonder, do you think white on black would look any, black on white would look better? Is this good? Okay. My IP address is, let's see here. It's not there. Okay. Okay, there I am. 172.16.2.88. Someone get ready to port scan me and I'll tell you to go. And we can watch the, we can see what happens. If I got a taker somewhere, you don't even have to stick your hand up, but, okay. Okay, 172.16.2.88. And we'll watch the log files here. Oh, we're going. Okay. So on the left, we see the alerts generating, and that stuff's all getting dropped. And on the right, you can see me logging all the packets as they're coming in, and those packets should all be getting dropped. Getting anything back? Okay. You're running Nessus? Great. So he's running Nessus. It's 172.16.2.88. Okay, let me make sure that let me make sure everything's running here. You are getting some SSH and LDAP? Yeah. Let's make sure of that. Yeah, let's see. 2.88. It's actually, you can see my IP address right there. It's highlighted. I need to figure out if I make sure I'm running the right rules file here. We're seeing a lot of traffic. How's Nessus doing? Yeah, typical. Has anyone tried Nmap against me yet? Is that what you did? Did you do Nmap? Okay. Let's see. I take it you're .74. Who's 239? Are you 239 over there? You may not want to say what your IP address is. I don't know how friendly the crowd is here. There you are. So you think you're getting some results back, huh?
21, 22, 9, 2002.
No. Now, one of the things I've noticed, and we've been playing with this some, a lot of scanners get confused because I'm dropping the packets, I'm not sending resets, and they'll retry, and in fact, I've had a couple people try to Nmap me using full connects, and it actually will starve their system of resources and make it crash. Because it doesn't reset any of the connections. You getting anywhere yet?
That says no open ports.
No open ports, yeah. Yeah, it should be very effective at dropping this sort of traffic. Again, if any of you are more interested in seeing this stuff in action or asking more questions, I'll probably be over at the Honeynet booth most of tomorrow. I'll be at Black Hat or at DEF CON a lot of the time, probably sitting on the Capture the Flag network somewhere, just watching people pick on it. And we'll see if anyone finds a way through. Yeah? It should perform just as well as Snort does on a high-volume network. You know, the main question, IP tables is known to perform extremely well at high volumes, and Snort is generally considered good to at least a couple hundred megabits. And some of the more recent Snort stuff, Marty and the gang have been doing a lot to improve the performance, and I think that on the right kind of system, you're good for close to a gigabit now. Yeah. The more rules you have, the more your performance is going to hurt. Now, my configuration here is probably really extreme. I would not, because I've got a whole bunch of the rules turned on. A lot of those rules are known for not being particularly accurate, etc. So the rule set I'm running, our typical rule set on Hogwash was 200 to 500 rules. The rule sets are usually quite small because there's not that many rules that are extremely accurate. A lot of the rules in Snort are more informational than they are actually detecting real problems. The question is, what sort of latency do we see? I haven't tested it yet. I honestly got a bunch of this stuff working just the day or two before I came here.
What kind of configuration roughly are you talking about for gigabit capability?
I can't really, his question is, what sort of configuration are you talking about for gigabit? I can't really answer that too well. The place to ask would be on the Snort users list, or ask the Snort developers list, or even call SourceFire or someone like that and talk to them about it. I don't have any personal experience with it. Well, I think we're pretty close to out of time. Let's try and get any last questions in.
I mean, for his case, he actually got some responses. Could it be that he got the first 20 packets?
Yes. Now, especially if you're using a targeted port scanner, his question was perhaps he got the first 20 packets. That's true. If you write a port scanner, it detected NIDs. Interesting. Nessus says HTTP NIDs, evasion, stuff detected, something like that. So it figured out there's some sort of NIDs in the way there. I'm not sure exactly what it saw. I'll have to look at Nessus and see what that's doing. You made a very valid point. You could write a custom port scan detector where if you're targeting, I mean, there's always a way around this sort of stuff. If you wrote a port scan detector that hits up front immediately 10 packets, the 10 ports you're most interested in, and you fire it, boom, you hit someone, you wait 60 seconds, boom, you hit the next guy, boom, you're going to circumvent it, until I notice in some other way you're doing it and tighten my constraints or just, there's always other ways. It's a constant war when you're doing this stuff. Someone will come up with a way to circumvent all this, and we'll come up with ways to break their circumvention, and it goes back and forth. Keeps it interesting.
I've also found that particular port scanner, I can't mark that port scanner.
Yeah.